Alright guys, so this is an introduction to confidence intervals, okay? This kind of takes us right before 8-1, okay? I think it's a good way to introduce the unit and the idea of confidence intervals. So we're going to get to this, but we're not doing that now, okay? So you can just write this in your notes as an intro to confidence intervals. Okay, so let's just say that 50% of students like tacos. Okay, let's say 50% of students like tacos, and you sample 25 students. Okay, so the population, 50% of the population of quote students likes tacos. I don't know how they got that information, but that's what they're telling us. And you sample 25 students. Okay, now with confidence intervals, we are going to switch our point of view. Okay, we're not ready for that yet, but we are. Okay, so if we're talking about this, then we want the mean of p hat, which is also equal to p, which is our population, and that's equal to 0.5 because they told us that was true. Don't know how we got that information, but they told us it was true. So if we wanted to check our conditions, we could do n times p greater than or equal to 10, n times 1 minus p greater than or equal to 10. This is our normal condition. Okay, this is our normal condition. So we're going to say 0.50 times 25 is greater than or equal to 10. And we're going to say 0.50 times 25 because it's 0.5. And p is 0.5 and 1 minus p is also 0.5. Okay, so both of those are greater than or equal to 10, so we can say that the normal condition is satisfied. Let's say we wanted to check our standard deviation, okay? Then we would do the square root of p times q, or p times 1 minus p over n, which is 0.5 times 0.5 divided by 25, which is 0.25 over 25, which would be 0.1. So I have a standard deviation, okay, of 0.1. The mean is 0.5. We could make a sampling distribution. We could make or create a sampling distribution. Okay, we're going to say an approximate one. We've learned that. Okay, we're going to make an approximate sampling distribution. What's approximate sampling distribution? It's really a pile of p hats. It's samples and samples and samples and samples and samples, and each p hat is a sample. Okay, so what you would do, what you would see is we have our distribution would look like this, right? We already talked about our distribution is going to be approximately normal. So in the middle we've got 0.5, and then we go up to 0.6, and we go down to 0.4, and then we go to 0.3, and we go to 0.7. Right? And all of these are our little p hats that are grouped underneath. Okay, and our p hats are going to pile up and become approximately normal. Okay, I could take a sample of 25 students and get a p hat. Now I might get some down here. I might get one way over here. These are rare, but they happen. Okay, they happen. You might go into this part of the cafeteria where kids hate tacos. You take a sample of 25 kids and none of them like it. Certainly possible. But if they're telling us that 50% of the population like tacos, we expect that it's going to be unimodal, okay, and it's going to be mound shaped, like a mound, and it's going to be mound shaped at the true mean. Okay, but it's still possible that you get some of these samples. Okay, it's certainly possible. Okay. So, we'll continue to talk about these tacos. Now what happens? Most of them pile up near the true mean. Okay? We also know that 68% of my p hats will be within one standard deviation, right? Mean 68. Mean 68. So 68% of my p-hats will be with one standard deviation. And then I know that mean 68, 95. 95% of my p-hats will be within 2 standard deviations, right? However, and this is where we're switching our point of view. How many times do you really know? How many times do you really know the true proportion of students who like anything? How would you get that information? Okay? When we are doing a confidence interval, okay, when we're doing a confidence interval, we don't know the true P. A lot of underlines there, okay? You don't know the true P. Otherwise, why would you, if you knew the true P, why would you worry about it? You would know 50% of students like tacos. Okay, that must be just what it is. But the reason we do these confidence intervals is because we don't know what the true P is. We're trying to find out what that true P is. Okay? We are standing, okay, at a p-hat. You're standing. You did a sample of 25 students. That's what you have to believe is true. You have to believe the information that you got from your sample is true. Okay? So we don't know how our sample relates to everything else. We don't know how weird our number, our p-hat is in relation to everything else. We don't know. Okay? We don't know that. Okay? We want to think this way. Ready? Think this way. If 95% of my p-hats are within 2 standard deviations, then from any p-hat, if I stood and reached out 2 standard deviations in both directions, I made a 95% confidence interval. Now, it's not exactly 2 standard deviations, and we're going to learn that. Okay, we're going to learn that. But it's going to be really close to that. And that's what a 95% confidence interval is. The most common of all the confidence intervals is going to be a 95% confidence interval. Okay? So the statistics tell us that we can take a sample and be 95% sure that the true mean of people who like tacos is going to be between 2 standard deviations of the sample that we get. Okay? And because of that, confidence intervals are parameter catchers. Okay? We want to use these confidence intervals to catch the parameter, to catch the true P. Okay? Catch that true P. So let's just say that p-hat was 0.65. Okay? So we're trying to find out all these people who like tacos. Okay? We sampled 25 students. And when we put all of our data together, we find that our p-hat is 0.65. So I would say, okay, I'm 95% confident if I am at 0.65, okay, if that's my sample mean, okay, that's my p hat, sample proportion, not mean, sample proportion, I'm 95% confident that between 45% and 85% of people like tacos. And how did I find that? Well, we knew our standard deviation was 0.1. So if I'm standing at 0.65, okay, this is where my sample is. And all I can do, all I can base my statements on, my findings, is based on the sample that I have. So if I'm at 0.65 and I reach out 2 standard deviations on each side, that's 1 standard deviation. I go up by 0.1. I go up by 0.1 again. I go down by 0.1. And I go down by 0.1 again. Okay? Then all I know, or my best guess, my best guess, okay, is that the true proportion of people who like tacos is between 0.45 and 0.85. That's my best guess. I'm 95% confident that's true. I'm 95% confident that between 45% and 85% of people like tacos. Okay? Let's say someone else had a p hat of 0.42. Okay? Their p hat was 0.42. So if I go up 2 standard deviations, 0.1 plus 0.1, and I go down 2 standard deviations, 0.1, 0.1, well, 0.42 plus 1 would be 0.52, plus 0.1 would be 0.62, minus 0.1 is 0.32, and this is 0.22. Okay, so this person thinks that it's going to be between 0.22 and 0.62. Why? Because that's what the sample was. Okay, so this person, we'll call this person Jerry. Jerry is 95% confident that the true proportion of people who like tacos is captured in the interval from 0.22 to 0.62. Okay? You could actually write it as an ordered pair like that. Okay? So, what do? You say, here's my sample. Okay? Here's my sample. Here's the information that I got. Here's my sample. If I go up and down by a margin of error, I'm pretty sure the true P is captured. Pretty sure it is. Okay? Let's say someone wanted a 100% confidence interval. They wanted to be 100% sure. 100% confidence interval. Okay? You'd say between 0 and 100% of people like tacos. Well, what does that tell you? Of course that is. That's why we don't ever see 100% confidence interval. You don't. Okay? Think of it this way. If you were fishing, picture yourself fishing. Okay? And you have a little net. You go fishing, okay? And you've got this little net. You wouldn't be too confident. You wouldn't be too confident you'd catch some fish. You just wouldn't be confident. But if I had a big net, you've got a big net, you'd be more confident. You'd be more confident. Okay? The confidence interval gets wider, but it's just not as accurate. Okay? All right. It's possible. Now, it's possible. It's certainly possible that you go out and take a random sample of 25 people and not catch P, catch the true proportion. Possible. It's absolutely possible. Okay? Let's say we're talking about a 95% confidence interval. Then 2.5% is greater on one end, right? You get this 95% confidence interval. It goes from here to here. You're going to have 2.5% out there. You can get 2.5% out there. You're not going to catch them all. Okay? Let's say your p hat is 0.26. P hat equals 0.26. Okay? And if you want to do a confidence interval again, we're going to use that 0.1. Okay? So there's 0.26. That's going to be 0.36. That's going to be 0.46. 0.16, 0.06. So I'm 95% confident that between 6 and 45% of people like tacos. That's based on my sample. You might go out and get a p hat of 0.26. Okay? That can happen. You go to this place where people just don't like tacos. Okay? Maybe people from Europe or something. I don't know. They don't like tacos. Okay? However, if you're only 95% confident, then 5% of the time you are going to miss P. Okay? You're not going to catch the true P 5% of the time. Okay? Now, here we go. 95% of the intervals you make will catch the true P. Okay? 5% will not. And sometimes if you look at a picture of this, the picture looks like this. They show you this true P here. And then underneath it, they have all these intervals. Okay? And the intervals go from wherever that person's P hat is, and it reaches out 2 standard deviations. Okay? So you look at all these intervals. 95% of these intervals will catch that true P. 5% are going to miss it. If your true P hat is down here and you make that interval and your interval looks like this, well, guess what? You're not catching that true P. And that's going to happen 5% of the time. Okay? So you're 95% sure the true mean is between, say for that last example, 0.46 to 0.06. Okay? It's not really true. Okay? Because it's either there or it's not. Okay? We're saying 95% of the intervals. It's the intervals. 95% of my intervals are going to catch that true P. Okay? Confidence lies in the intervals. Okay? This is also not correct. 95% of P hats are between 0.06 and 0.46.